Hello, folks. This video covers the first semester exam study guide. So, of course, you can skip forward to particular questions that you need help with, or you can just kind of stick with me from the get-go, and it'll be a great way to review for your test. So, number one discusses domain and range, obviously, hopefully. Remember, domain deals with x values. Oh, lovely. X values, range deals with Y values. So I wanted in two different types of notations. First being inequality notation. Now I'm actually going to combine set notation and inequality notation. So you'll see what I mean in just a second. So the domain, if it's dealing with X values, X is, we always start with the smallest. So I want to know what is along my X axis, right? X values. What is the smallest X value that my graph touches? In this case, it is -4. So I start at -4, I can continue on, and it goes into infinity, essentially, right? It covers all of these points because that arrow shows it goes on forever, except this -2, right? There's an open dot there. So I can say my domain is the set of all x's such that it can equal -4 because that was a solid dot. So x is greater than or equal to -4, but, or just put a comma, x cannot equal -2. And so technically that's in set notation. You also could just write what I have underlined here in red. X is greater than or equal to -4, but x cannot equal 2. Okay, so for the range, I'm going to say it's the set of all y's. Again, we start with our lowest y value. Now, this arrow here indicates not only does it go to the right forever, but it goes downward forever. So I know it goes all the way to -infinity on the y's, and it keeps coming up, and it stops at this point. I cannot get any higher of a y value than that, which that has a y value of 3. So, and it can't touch it because it's an open circle. So I'm going to say my range is the set of all y such that y is less than 3. So again, this is, even though I did mine in set notation, I make use of the inequalities. So I would take either one of those. Now, interval notation deals with the parentheses, right? So if we have something like this, that's where if you have an open circle, and if you have something like this, well, you can that's if you have a coordinate or either one of the infinities, and use the brackets if it can equal those numbers. Okay, so I'm doing the same domain and range, but just a different notation. So back to domain, my smallest domain value is -4. It can equal -4 because it was solid. So I'm going to start at -4. It goes all the way, continues to the right until this point here where it opens up, and that's at -2. So -4 to -2, it cannot equal it. So I put a parenthesis. It picks back up, we'll say again at -2, and it carries on forever to infinity, and with infinity we put the parenthesis as well. This U in the middle means in union with. It's just a fancy way of an and symbol saying I use this interval and this interval to discuss the domain. The range, the smallest y value, we said this arrow indicates that it goes downward forever. So that's going to be a smallest y value of -infinity, and it goes up all the way until it hits 3, at which it cannot equal it because there's an open dot. So I put a parenthesis there. So the range in interval notation will be -infinity to 3. Number 2, sketch a graph of the piecewise function denoted by f of x equals, and then it gives me two functions here, and then determine its domain and range. So let's start with the x squared. We know that x squared is just a parabola. It's a parabola at the origin. So parabolas look like this. 1, 1, 2, 4. And ta-da, you have a parabola. Now, the issue is the domain. We only want this parabola when x is less than 0. When x is less than 0, that means I don't want anything to the right of the y-axis, so I'm going to erase all of this. And it also cannot equal 0 with this function, which means I also need to put an open coordinate right there for x is less than 0. Okay, so there's the first one, x squared for when x is less than 0. The second function is the square root of x plus 1. Now you have to remember the parent function for the square root of x looks like this. And you also have your graphing calculator that you can use to help you. But it's that function plus 1, meaning instead of starting at the origin, it starts at 1. And it can equal that because it is x is greater than or equal to 0. So it's going to be a solid coordinate. And then it'll be to the right 1, up 1, something like this. And again, that's x is greater than or equal to 0. There's nothing to erase because that function doesn't even go to the left of the y-axis. So again, you can graph both of those in your calculator for guidance, but you may only need pieces of them. Now, for domain and range, domain is dealing with the x values. So the smallest x value, now this blue part will go up, but it also goes to the left forever. So my smallest x value is negative infinity. It keeps coming, keeps coming, keeps coming until it gets to 0. Even though it looks like it's open at 0, it's not open because that's where the green function actually picks up. So it's continuous there. I mean, there's discontinuity at that point 0, but your function is defined at 0, and then it keeps going all the way to positive infinity for the x's. So your domain is actually all real numbers. It starts from negative infinity, goes all the way to positive infinity. Your range, the smallest y value that we have is at this 0 where it's an open circle, and then it goes up forever. So our range is just going to be y's that are greater than 0. And you could put set notation or inequality notation or interval notation. So there's your domain and range. Number 3, find. So we've got functions here. Find g of t minus f of t given the two functions. So you got to be careful here with that minus sign. So let's go ahead and write g of t first. So g of t is 3t minus, I'm going to put the entire function f of t in parentheses. So I've got t squared minus 3t. So what you got to be careful with is just this minus applying to both of these terms in parentheses. So then I've got 3t minus t squared, right? It distributes there. And negative 3t will change to plus 3t. So then when I simplify this and kind of reorder everything, I get negative t squared plus 6t. Number 4, find g times h of n. In other words, I just want you to multiply these two functions together. So I've got g of n is 2n minus 4 times h of n is n cubed minus n squared. When I multiply, I'm just distributing these 4 times. So 1, 2, 3, 4. So 2n times n cubed is going to be 2n to the 4th. 2n times negative n squared will be negative 2n cubed. Negative 4 times n cubed is negative 4n cubed. And negative 4 times negative n squared will be positive 4n squared. And then I'm just going to combine my like terms and simplify. So then I got 2n to the 4th. I can combine, sorry if you'll hear my dogs fighting in the background. They're annoying me, but I'm not stopping this video. Then these two are like terms because they're both cubic. So that's going to be negative 6n cubed plus 4n squared. And this is as far as we can go. We cannot combine or simplify any more than that. Number 5, find f of g of a. Composition of functions seem a lot trickier than they actually are. F of g of a, I can rewrite to be f of g of a is this function 2a plus 3. So I technically want f of 2a plus 3. So this means in the function f, everywhere there's an a, I'm plugging in 2a plus 3 instead. So then I've got 2a plus 3 squared plus 2 times 2a plus 3. Okay, and then I just want to simplify. So what you got to be careful of here is that this 2a plus 3 squared is 2a plus 3 times 2a plus 3. And then you can distribute this 2. So that's going to be plus 4a plus 6. Okay, so then one more time, we're going to distribute this 4 times, or FOIL, if you will. So 2a times 2a is 4a squared, plus, that's going to be 6a plus 6a is going to be 12a, and then 3 times 3 is 9, plus 4a plus 6. And then if we simplify, combine our like terms one more time, we've got 4a squared, and then 12a plus 4a is 16a, and then 9 plus 6 is 15. So there's our composition of functions. Okay, another one like that. F of g of n could be written as f of g of n is 3n cubed plus 4 plus n. Plus n. Okay, so this means in the function f, everywhere I see an n, I'm plugging in this instead. So 3 times 3n cubed plus 4 plus n plus 2. And then we're going to distribute that 3. So this could be 9n cubed plus 12 plus 3n plus 2. And then when I rearrange a little bit and add some like terms, I get 9n cubed plus 3n plus 14. Number 7, graph f of x is less than the absolute value of x plus 2 minus 4. Things to remember. And first of all, absolute value functions look like this. Secondly, with this less than symbol, that means we're going to have a dotted line. So you got to be careful with that. Making sure not to just draw your graphs, without paying attention to those inequalities sometimes. That dotted line means we're also, because it's just a less than, but because it's not an equal sign, we also are going to have some shading that we have to deal with. X plus 2 indicates that we are actually going to shift this function to the left 2. Remember, that's opposite. And then minus 4 is going to go downward 4. Okay, so my vertex is actually going to be to the left 2 and down 4. And then I'm not changing the slope at all. So it's 1, 1, 1, 1 like this. And remember, it's a dotted line. Because it's an inequality, we have to deal with some shading. So I'm going to pick a test point. You can pick any kind of test point you want. A lot of times you pick 0, 0. Looking at my numbers here, I'm actually going to pick the coordinates -2, 0, which is right here. Okay, so if I'm going to choose that coordinate, that means that for where I have x, I'm plugging -2. Where I have y, I'm going to plug in 0. So remember, f of x is y. So 0 is less than the absolute value of -2 plus 2 minus 4. So then I get 0 is less than -2 plus 2 is 0. And I get 0 is less than -4. This is not true. So that means the point -2, 0 is not a solution, which must mean all of the points on the other side of the function are. So you're going to shade the bottom portion like that. Number 8, solve the following systems of inequalities by graphing. So let's do the first one in blue. So x is less than -1. For this one, you can pick a test point if you would like. Well, first of all, let's graph it. X is less than -1 is going to be a vertical line. Again, it's just a greater than, not an or equal to. So we're going to have a dotted line at -1. And if we test the points 0, 0 if you want, then we get 0 is greater than -1, which is true. So that means we want to shade on top of 0, 0, or we want to shade to the right. Eventually, I don't want to shade just yet because we might have to erase some of it. So let me go ahead and deal with the second one. So in 2y minus x is less than or equal to -4, to graph that, I'm going to add x to both sides. So then I get 2y is less than or equal to x plus 4. Divide everything by 2. I get y is less than or equal to 1/2 x plus 4 over 2 is 2. So when I graph that, I'm going to be up 2 on the y-axis, and then a slope of 1 over 2. So rise 1, run 2. And then that's a less than or equal to, so that one's going to be a solid line. And then when we test this one, I'll test 0, 0. I get 0 is less than or equal to 1/2 times 0 plus 2, which is going to be 0 is less than or equal to, this is 0, 2, which is true. So in relation to the red line, 0, 0 is on the bottom. Okay, so I need to shade the area that is below the red line, but to the right of the blue line, which is this part right here. So these two are where they overlap, and you could shade everything and then just erase, like technically this would have been blue, and technically this over here would have been red, and then you can erase that after, but the part where they overlap is your answer. Okay, number 9. Perform the indicated operations. If the matrix does not exist, write impossible. You got to be careful here with these double negatives. This first matrix, -2, -1, we'll just stay put for a second. And we're going to have minus. I'm going to go ahead and distribute this -2. It's just a scalar.